Alright, we're going to finish up now with more factoring strategies. So here again, we have a problem, and our first rule is always to factor out the GCF. In this case, we actually do have a GCF because there is a 3 that is common to both terms, and they also both have r's in them. They both contain an r squared. So r squared is the largest thing we can pull out of both of those. They don't have an s in common, so the greatest common factor would be 3r squared. So whenever we factor that out, or kind of reverse distribute, we have r cubed minus 8s cubed. Now because we have two terms left, it has to be either a difference of squares or a sum or difference of cubes. So this looks like it's cubes, and it looks like it's a difference. So in order to follow the pattern properly, we probably want to write out, what's being cubed so we can see our a term and our b term. So what do I have to cube to get r cubed? Well, that would be an r. And what do we have to cube to get 8s cubed? Well, that would be 2, because 2 cubed is 8, and s. That tells us that r is our a term and 2s is our b term. And then we would follow the formula. The formula says we take a minus b times a squared plus a times b, which would be 2rs, plus b squared. When I square 2s, we get 4s squared. Now don't forget, we had already factored out that 3r squared, so we have to bring that back down again. So this is our final factorization of that problem. Alright, we have one more, and it's a very interesting problem. Here we have 2y plus 3 squared minus 5 times 2y plus 3 plus 6. Now we've not done any factoring where what's being squared was more than just an x or a y or an r or something like that. So wouldn't it be nice if this was just something squared? We can actually do that. This is called u substitution, when we let u equal 2y plus 3. So what we're going to do is say, you know what, 2y plus 3, I'm just going to call that u. So everywhere I have a 2y plus 3, I'm going to change that to a u. Now, if I rewrite my problem, we have u squared minus 5 times u plus 6. Now that is a whole lot easier to factor. We do not have a greatest common factor, which is, of course, what we always do first. We have 3 terms, so that tells us to factor by trial and error, because that first term is a 1. So when I factor this down, we would have u times u would give us u squared. Now we have to think of two things that multiply together to get 6, that somehow I'm going to get a 5 out of the middle. Because these signs have to be the same, then they're both going to be negative. So we're going to be adding two things together to get 5. That tells us it has to be 2 and 3. Now, this is how this factors, but we did not start out with u's. We started out with 2y's plus 3. So now we have to go back and back substitute. Everywhere we had a u, we need to replace that with 2y plus 3. And now we can simplify this, because 2y plus 3 minus 2 simplifies into 2y plus 1. And 2y plus 3 minus 3 simplifies to just 2y, because our 3's will cancel. Now because we have a monomial and a binomial, generally we write the monomial first. So it would be 2y times 2y plus 1. And this is our final factorization of this original problem.